Alright, so example 1, I'm not going to take the time to write it. I'll just say it again. 4, 12, 36, 108, and 324. Example 2, the first term is 24, and the common ratio is 1/3. So we're going to be multiplying by 1/3 every single time. So that's going to give us 24. 24 times 1/3 is 8 times 1/3 is 8 times 8/3 times 1/3 is, and 8/9 times 1/3 is 8/27. Geometric sequences you're multiplying every single time. Arithmetic sequences you're adding every single time. 3 is just giving you the same information, except they're giving it to you with a recursion equation. So a to the n minus 1 says you just go back to the previous term and you multiply it by -3. You go back to the previous term and you multiply by -3. So they're telling you that your common ratio in example 3 is -3. So the first term is 10, then you do -30, 90, -270, and 810. Same thing, same exact problem, except you're not adding. That's called the common difference. You got a common ratio, and that's the number that you're multiplying every single time. Next set of directions say use the formula for the general term, nth term. We're doing the same exact thing, except we're doing geometric sequence instead of arithmetic sequence. Okay, you do have some formulas that you're going to have to memorize. I think there's going to end up being 4 formulas that you're going to have to memorize for that last quiz, and we'll talk about what those are later on. So it says write a formula. Okay, so you got a sub n. Actually, it's telling you to use the formula. So we're finding the 12th term. Okay, so we're doing the 12th term. So a sub 12, according to the formula, equals the first term, which is 4, times the common ratio, which is -2 to the n minus 1. And in this case, n is 12. So 12 minus 1 is 11. So it's going to be 4 parentheses -2 close parentheses power key 11. I'd probably put all that in my calculator. That's going to give you -8,192. Why is it negative? Why can't I just look at that setup and know the answer is negative? Negative number raised to an odd exponent. Same thing with example 5. You're finding the 30th term in the sequence. So you're going to do a sub 30 equals the first term, which is 8,000, times your common ratio, which is -1/2, to the n minus 1. N is 30. 30 minus 1 is 29. You'll plug that in your calculator, and you'll get a really what? Small number. Probably should have rounded, but I didn't. Alright, so it's very similar. The formulas are going to change because we're not adding every single time, we're multiplying, so the formulas have to change for that. Next set of directions say write a formula for the general term, nth term of each geometric sequence, then use the formula for a sub n to find a sub 7, the 7th term in the sequence. Okay, so we're going to start out with a a sub n equals a sub 1 times r to the n minus 1 and plug in what we know. We're going to leave it as a general form though. So we're going to do a sub n equals, we can plug in a 3. We can plug in the common ratio. What are we multiplying by every single time? 5. And then we're going to leave it general. So that means we're going to leave it with the n's in there. That's what they're asking you to do. Write a formula for your sequence. Write a general term formula. So you got to do that first. Then it wants you to find a to the 7th. So then you just plug it in. A sub 7 equals 3 times 5 to the n minus 1. 7 minus 1 is 6. You'll punch all that in your calculator, and you'll get the 7th term in the sequence, which is 46,875. But you'll find the general term equation first. All right, y'all try number 7. What's our common ratio in example 7? -1/5. Alright, so for example 7, your general term formula is a sub n equals 5, the first term, times the common ratio, -1/5 to the n minus 1, and then you're supposed to find the 7th term. So it'd be a sub 7 equals 5 times -1/5 to the 6th power, and what'd you get for that? That's what I got, 0.00032. I will probably give you these formulas, even though I'm asking you to memorize them. I want you to try to memorize them, but I'll most likely, if you'll ask me, I'll give you the formulas. I'm not sure if y'all can remember your name at this point. I don't know. Alright, last section. Use the formula for the sum of the first n terms of a geometric sequence to solve. So we're finding the sum here. We're just doing it with a geometric sequence. They've got us a nice little formula. So if we're doing example 8, we do S sub 12 is equal to 3 parentheses 1 minus 2 to the 12th divided by 1 minus 2. So you might have some calculator issues. You may have to go in and either hit equal, but you got to calculate the top, and then you've got to divide that by -1. You probably can just do the divide by -1 in your head since it's -1. Tell me what you get for this one. It's a pretty big number. 12,285. Alright, last one. Find the sum of the first 14 terms of the geometric sequence. Find the sum of the first 14 terms. I'm just going to go back. So that's going to be S sub 14 is equal to the first term, which is -1 over 24, parentheses 1 minus, what's the -2 to the 14th, close parentheses, all over 1 minus -2. That was a little bit more complicated. Could simplify just a little bit before you put it in your calculator. You might want to go ahead and just say the bottom is 3. I have a decimal answer and a fraction answer, so I'm not sure what your calculator will give you, but we'll talk about it. Anybody getting a fraction? Anybody getting a decimal? 227 point. Okay, so I have 227.541, whatever. And what if they wanted a fraction? Everybody know how to change decimals into fractions with your calculator? You should have a key that has an F, and then it has a double arrow, and it has a D. I think it probably have to hit second button, and it'll change any decimal back to a fraction. I have a fraction written because probably that's what the book has. 5461 over 24. But I'll take either one of those. Okay? It'll probably be 17 if we rounded. Alright, y'all practice a few of these. I will, even though I'm asking you to memorize the formulas, I will give you the formulas on Tuesday. If you'll remind me, I'll just write them all on the board.